We are in Module 15. That will be the last lecture module for this class. We will introduce recursive functions. You can find in textbook from Chapter 19. We won't be able to cover the whole Chapter 19, but we will talk about the fundamental concept about the recursion function. And also we will give you some typical example that using the recursive function to solve the problem. So the first thing we will talk about what is recursion. Then we will give you two cases. Two cases they are solving by the recursive function. The first one is factorial. The second one will be the Fibonacci sequence. Then in the lab exercise, I will show you how to use the debug mode to see from the IDE that will help you to solve the problem in the future class. So on Wednesday's class, I will continue to review the recursive function characteristic. Usually the recursion function, the problem we solve from the recursion function, they can use in an iteration as well. So we will compare the difference between recursion function and the function using the for loop. So the last one, I will show you a very famous example we solved from the recursion. That will be the Tower of Hanoi. So the first thing that start, what is recursion? So usually the recursion function is we talk about as recursive function. A recursive function actually, of course, they're a function. So you should know what is function, right? So function have the return type. We call the function by name, and we will pass in the parameter if you need. So a recursive function is a special function. In the function body, it will call itself, either directly or indirectly. So when we say directly, that means in the function itself, they call itself. So that means if you have a recursion function inside the function body, you call itself again. That's we call they call directly. Or indirectly, that means a recursive function will call another function. Then this function will call back for the recursive function. So that's we call recursive function. So recursive function, you can see we start a function call, but this function didn't execute from beginning to the end. They will call another function. So then another function, of course, we should execute from beginning to the end. But this function maybe call another function again. So that's why recursive function kind of is a nested function. You call function 1, function 2, function 3. So you only wait until the function 3 finish. So then they return to function 2. Then function 2 return to function 1. But just recursive functions, sometimes they don't have function 1, function 2, function 3. They only have function 1. So this function 1 call function 1 again, then call function 1 again. So then we see how they will work. You say if they call again and again, when they will finish. Right, so that's very important. Recursive functions, sometimes it may not be finished. So they will become an infinitely code. So that's very dangerous. So that's why when we implement the recursion function, we need to make sure even they can call itself, but in the implementation, we need to find a way to end the function code. So let's continue. Recursive function actually is, we say, using to solve the recursive problem. So the recursive problem, actually, they are very special problem. Their solving approach actually have a number of elements in common because not all the problem is recursive. Only recursive problem, we will write a recursion function for that. So what those problems in common? The first thing, a recursive function is called to solve a problem. Right, if we want to get the answer, you call the function. But this recursion function actually know how to solve the problem only on the simplest cases. Those simplest cases, we call that the base case. Sometimes you can have one base case, sometimes you can have multiple base cases. But we have to have the base cases because the base cases is the only way we know how to solve the problem. For example, you know 1 plus 2 is 3. So then you know 1 plus 2 plus 3. So you need to continue to plus, right? So so that's why here we always know 1 plus 2. We can get the value. But how about 1 plus 2 plus 3 plus 4 plus 10 until 10? Do you know the answer? Yeah, you say you can add one by one, right? But one thing is, we need to call a function to solve for that. So recursive problem is, they have a function call to solve the problem. But the problem itself, intuitively, we only know how to solve that with the simplest case. Those cases, we call that base cases. So if the recursive function is called with the base cases, then the function will simply return a result, because we know how to solve that problem. But if the function is called doesn't have a base cases, they are with a more complicated problem, that's still fine. Because this problem, if they are more complicated, right, that usually is a recursive problem. It's very complicated, but they always can divide the problem into two conceptual pieces. A pieces that the function know how to do, and the pieces that doesn't know what to do. And when they doesn't know what to do, they can make this problem can be simplified. So once the problem you don't know how to do, right, but they can simplify into a simplest one. So that means if you have more complicated problem, that's fine, because they always can divide this problem into a smaller one. And also this smaller one actually is similar as the original problem. So that's we call that's a recursive problem. So what does that mean? I know you have some question. So that means here we need to see the example so we can show you what means recursive problem. So this problem I want to using the factorial to show you. Do you know what is factorial in math? Right, the math factorial we talk about, for the factorial for n, we write as the n exclamation mark. But this exclamation mark is a factorial. So this definition means we start from n times n minus 1 times n minus 2 until you times 2 times 1. So that's what we mean factorial. So n factorial actually means is the product from 1 times 2 times 3 until you times n. So of course we know 1 factorial equal to 1. But be careful, 0 factorial we have definition as well. Because remember we say the factorial means that the numbers start multiply, right? So that's why 1 factorial is 1. But the 0 factorial in math we define is 1 as well. So this one actually is very typical recursion function. Why? Okay, so you see here. We see why they are a typical recursive function. Because when you see that, n factorial, can you tell me n factorial equal to n times n minus 1 times n minus 2 times 2 until you times 1, right? So don't you agree? N factorial actually equal to, you see that we say n factorial equal to n times n minus 1 times n minus 2 until we times 2 times 1. So don't you agree? From this part after the n, this one is what? Right, this one is n minus 1 factorial. So on the other hand, that means when I want to find n factorial, I just need to find n minus 1 factorial first. Then I times n. Then I got n factorial. Pause the video, think about that. Do you agree with me? Right? So whenever we try to find n factorial actually means n times n minus 1 factorial. Very good. That's what we mean recursive function. Recursion always means when you have a original problem, your original problem is n factorial. I can divide this problem into a smaller cases. Do you know n? Right. When I want to find n factorial, I just need to find n minus 1 factorial first, then times n, then I got n factorial. You agree, right? Right. So that's how about we write a function. We call this function is the factorial of n. So that's I call this function I call factorial. Okay, so this factorial function I pass in the integer n. They will return me the n factorial. That's the function. Okay, that's my function definition. I have factorial function, you passing me the n, then I give you n factorial. You agree, right? Very good. So that's why, do you agree earlier we say, if you have n factorial, actually they equal to n times n minus 1. Right, so that's me. This n factorial actually equal to the n times n minus 1 factorial. So what is n minus 1 factorial? Right, n minus 1 factorial, I just need to call the factorial function again, right? Right, so this one is we call the recursion function. Recursion function is using to solve a recursion problem. So this problem always can have the complicated problem divide into a smaller pieces but a similar problem, like n factorial equal to n times n minus 1 factorial. So now I decide I want to have a function called factorial n. So this factorial function I pass in the n, I will return the value for n factorial. So this n factorial actually is n times n minus 1 factorial, right? So n minus 1 factorial just means I call this function again, I pass in n minus 1. Wonderful. So that's what we call, you see, recursion function is a function call itself. Did we complete this function yet? No, because remember we say what? Earlier I told you, right, when we say recursion function, we try to solve the recursive problem, right? So this recursive problem, they always to solve the more complicated problem and divide that into a similar problem and a base cases. So that's why this function, when they be called, right, they always need to be two conceptually pieces. So what's that? Actually, that's the base cases we don't have. So here, what we do is we didn't complete yet because we're missing the base cases. Okay, so we're missing the base cases. Where is the base cases? Right, so that's at the base cases. Did you remember what is the base cases for the n factorial? Here. The base cases is when n equal to 1, the result is 1. N equal to 0, 0 factorial is 1. So that's why we have two base cases. So here we need to add the base cases. Okay, so when we're coming back, we need to have if n equal to 1 or n equal to 0. Okay, so that's the base cases. So what is the base cases? When n equal to 0 or n equal to 1, 0 factorial or 1 factorial equal to 1. Very good. So that's why in the base cases, if n equal to 1 or equal to 0, so that's we return 1. Okay, so right, so here earlier we say when we have n times n factorial n minus 1, right? So this one is the similar and smaller cases. That one I will do the n times factorial n minus 1. So that's now we have the factorial function ready. So you see here, when we have n factorial, I pass in the n, right? So then this n factorial, like earlier we say, right, they have base cases. So those base cases, we use the if-else statement. So when n equal to 1 or equal to 0, I return 1. Otherwise, I return n times I call factorial function again, but I make the smaller pieces. I find the n minus 1